Suppose we have the following circuit. We have a load connected in the star and delta, another that is connected in delta. First one, the impedance is capacitive, is equal to 176 minus J 132. In polar form, this is 220 and minus 36.87 degrees. The second one is connected in delta, and the value is 198 plus J 264, and we want to replace it first of all by an equivalent star. So we can change by dividing the delta by 3, so we get Z second in star, which is equal to 66 plus J 88, and this will give us 110, and the argument is 53.13 degrees in ohms. So we are asked to calculate the main current, the power dissipated in these two loads, and later we are asked to calculate the capacity of the capacitor put in parallel with the loads that corrects the power factor to 1. Okay, so let's start. First of all, let's draw the equivalent circuit of one phase, because the circuit is symmetrical. So we can calculate I1 prime and I1 2 prime. So this will V1 over Z, I called it Z prime. This one we called it Z2 prime, and Z prime, this is 220 and minus 36.87, and Z2 prime, this is 110, and the argument is 53.13 degrees. Okay, let's calculate the first current. This is 220. We take V1 as a reference, so 220 minus 36.87, this will give us a current of 36.1 amp, an argument 36.87 amp. Write it here. This is 0.8 plus J 0.6 in algebraic form, E1 2 prime, this is V1 over Z2 prime, 220 over 110, 53.13, this will give us a current of 2 minus 53.13 degrees, so the result is 2 minus 53.13 degrees, and in algebraic form 2 times cosine 53, 06, 1.2 minus J 1.6 amps, and we calculate the main current. Main current I1 is equal to I1 prime plus I1 second, and this is 1.2 minus J 1.6 plus 0.8 plus J 0.6, and this will give us a current of 2 minus J, and this is in polar form. In polar form will give us the square root of 5 minus 26.56 amps. Okay, now we can calculate the power. We can calculate S, it's square root of 3. Remember that the line voltage is 308, phase voltage is 220. So this is it, square root of 3 times 380 times square root of 5. This will give us a power of times that is 1471.7 volt amps, and P is equal to square root of 3 U times I1 cosinus phi, which is cosinus 26.565. Its cosinus phi is 0.894. Sinus will be, sine of this is 0.447. So we can calculate this is 1471.7 times 0.894. This is Q is square root of 3 E1 sine phi, and this will give us times 1471.7. This is 658.16 vars, and here it's 1471.7 times 0.894. This is 1315.7 watts. Now we try to compensate the circuit to have, let's calculate C, the capacity of the circuit when it's connected in star. So Q should be equal to QC. To compensate this, we want a new power factor of 1. So Q should be equal to QC. If it's connected in star, it means it should be equal to 3C omega V squared. So, but if it's connected in delta, it should be equal to this. So let's calculate this first. Capacity when it's connected in star, and it's 658.16 divided by 3, 2 pi times 50 times 220 squared, and this will give us 658 divided by 10 divided by 3 divided by 220 divided by 220. This is 14.44 microfarads, and C connected in delta should be 1/3 of this, which means 4.8 microfarads. That's it. We have calculated everything, and I thank you for your attention. Thank you.